Hello everyone again, it's Mr. Wolf here. If you are watching this video, then that means that you completed this page right here. I just wanted to quickly go over the answers. So our net force and our acceleration, as net force increases, acceleration increases, so they're directly related. And as we increase mass, acceleration actually goes down. So these are inversely related. So even though I don't have the directions on this sheet, it just didn't print, on page 24 for you, right, it says write your dependent variable on the left side, so that's acceleration. That was right here. And then it says that if your independent variable is directly related to your dependent variable, it should be placed in the numerator. So F net and acceleration directly related, so in the numerator. And then if your independent variable is inversely related to acceleration, you put it in the denominator. So my equation ends up being acceleration is equal to the net force divided by the mass. Right? This is a really, really, really important equation. And what I want to do now is get a start with actually applying it. So if you go to page 25 of your packet, and I'm realizing for you guys that it might be page 24. So the packet that I have that printed out obviously had a little bit of different numbers, but hopefully you could see just by the image what page you should be on. So here, some basic equation practice. Remember, my equation is acceleration is equal to F net divided by mass. All right. I also have like my F net equation. F net x is equal to, and then whatever the forces are there, and F net y is equal to whatever the forces there are in the y direction. So some basic equation practice. If the mass of a box is 15 kilograms, remember this is just general problem solving. Kilograms, by the way, is mass. It also says it's mass. So mass is equal to 15 kilograms. And the box is 6 newtons. Newtons is force. It also tells me it's force, luckily, in this case. So F net, and it also says it's the net force, is equal to 6 newtons. What is the acceleration of the box? Right, so in terms of what equation I'm going to use, well, I'm looking for acceleration, and I have these variables, so that's what I'm going to do. I'm going to say acceleration is equal to F net divided by mass. My acceleration I'm looking for, my F net is 6 newtons, and my mass is 15 kilograms. So when you do the math on this, you end up getting acceleration is equal to 0.4 meters per second, or you could do meters per second squared. Both of those are valid units for acceleration. All right. So now I'm going to look at interpreting basic force diagrams. So it's essentially the same thing, just a little bit more of upfront work. So I have a 5 kilogram box, and by the way, I like to get in the habit of always putting the mass in the drawing of the object. And so mass is equal to 5 kilograms. Experience is the force is shown. What is the acceleration of the box? So if I'm looking for acceleration, I know that with this equation, I need to know my net force first. And if I'm looking for my acceleration, I know that this is the equation I'm ultimately going to use, because that's the only one that has acceleration at this point. But first I have to find my net force. Luckily I could do that. I could just do my F net x equation. F net x is equal to my forces to the right, 7, minus my forces to the left, 22. So my F net of x is equal to negative 15 newtons, and then I just will plug that in for net force right here. So then acceleration is equal to the net force I just calculated, negative 15, divided by 5, my mass, and I'm going to get an acceleration of negative 3 meters per second squared. So let's try to take a step back really quick. By the way, my net force is a negative number, which means it's going to the left. Right? If you remember, net force causes acceleration, and they're directly related. So whatever direction your net force is going in, your acceleration always goes in the same direction. So my net force is negative, and so is my acceleration. That checks out. So what I want you guys to do is try to work on the rest of the problems on this page.